In this lesson, we're going to learn about how right triangle trigonometry works. We're going to define the trigonometric ratios, sine, cosine, and tangent, and we're going to use it to solve some problems about right triangles. So first, let's look at the definition. If I have a right triangle and I have another right triangle, there's no guarantee that they're similar, because in order for triangles to be similar, we have to know that they have two angles that match. But if I tell you that both of these angles here are angle A as well, so these angles also match, then these two triangles have to be similar. Remember one of the consequences of similarity is, this length might be different than this. This length is going to be different than this. But if I take a ratio of two lengths here, it's going to be the same as if I take the corresponding ratio here. For example, if I do some figuring things out and I've determined that this is exactly half as long as this hypotenuse here, then this would also be true here. This would be the ratio of this to this would be 1/2. And so we use that fact that these are similar triangles to define what are called the trigonometric ratios, which are extraordinarily important for solving triangles, problems involving right triangles, and moving forward into pre-calculus. So in order to define these trigonometric ratios, we first have to know how to label a triangle for trigonometry. So when you're going to be doing trigonometry, you always will have a right triangle, at least here at the beginning, and there'll be an angle that's sort of the angle you're going to focus on besides the right angle. So you always have the right angle and then another angle that's this is going to be the angle that we're going to use to define our trigonometric ratios. It could be this or this, but you have to pick it at the start of the problem. If there's an angle that's given, then choose that one. So I'm going to work with this angle. So the way we label a triangle for trigonometry is first, since this is a right triangle, we always label the hypotenuse. That's always across from the right angle, as you probably remember. So this is going to be the hypotenuse down here in this triangle. And we label it HYP for hypotenuse. I'm always going to use 3 letters. Next, the other two sides are labeled in their relationship to this selected angle. We're going to have the adjacent side, and then we're going to have the opposite side. The adjacent side is the other side that this arc for the angle touches. It's going to touch the hypotenuse, then the other one that it touches is the leg that is adjacent to this angle. And then going across from it to the opposite side of the triangle, we find the leg that is opposite this angle. And this is the order that I recommend you label the 3 sides: hypotenuse, adjacent, opposite. Let's try it on this triangle. If we try it on this triangle, then here's the right angle, hypotenuse first. So across from the right angle, I find the hypotenuse. Then here's the angle we're working with. This is the adjacent leg. And over here across from it is the opposite leg. Okay, one more. See if you can do this one. Okay, you should have across from the right angle, hypotenuse. Then here, adjacent to this angle that we're working with, we have the adjacent leg, and then across we have opposite. It's very important that you always have an angle that you've chosen to work with that's going to define the labeling, and that you do this correctly, because if this is incorrect, it's going to mess up what follows. So what are the trigonometric ratios? Well, let's suppose that we have a triangle that we have correctly labeled. Here's the angle that I'm now going to call A right now. So here it is correctly labeled for trigonometry. If you remember from the first sheet, any ratio of these two pairs is going to be the same, even if I make this triangle a bigger or smaller version of itself. Because having these two angles given means if I shrink it or grow it, I'll always end up with a similar version. So that means, like, if I do this over this, it's always going to be the same. So the 3 trigonometric ratios are defined as follows. The first is called the sine ratio. That's always abbreviated SIN. And the sine, you never write the SIN by itself. You always write down right next to it the angle. That's sort of the selected angle in the triangle that you're going to be working with. So this is read sine A. The sine of A is defined to be, this is what it means, this opposite length divided by the length of the hypotenuse. That is the sine ratio. If this is a little bit confusing, it will become clear as we show you how these work. The cosine ratio is always abbreviated COS. We always write the angle right after it, the chosen angle we're working with. The cosine ratio is adjacent over hypotenuse. Whatever these two lengths are, we divide them. That's the cosine of that angle. And then finally, the tangent ratio is opposite divided by adjacent. You need to memorize these definitions. And there's a silly mnemonic that is often used. SOHCAHTOA, to remember how these are defined. SOH is reminding us sine is opposite over hypotenuse. CAH is reminding us cosine is adjacent over hypotenuse. TOA is reminding us tangent is opposite over adjacent. You have to have these three ratios memorized, and this is a helpful little trick. So what? So what have we done here? How is this useful? I mean, in what I'm saying here in essence is, if I measure this angle exactly and I know it's 27 degrees, and then if I were to measure this out precisely and measure this out precisely and divide those lengths, then I could figure out what the sine of 27 degrees is. Sine of 27 degrees is going to be this opposite over this hypotenuse. But this wouldn't be very helpful if I had to measure every time if I wanted to figure out what sine 27 is. What makes these useful is that we can look up these values. These are established values, sine of 27 degrees and cosine of 56 degrees and tangent of 18, all the different possible values for sine and cosine and tangent, we can look them up. Back in the day, before technology was cheap, the way you would look them up is you would go to a table that looks something like this, where it would list, all right, here's 1 degrees, and here's the sine and the cosine and the tangent of 1 degrees, and so on and so forth. This goes all the way down to 45, and then it goes again 46 to 89 degrees. It doesn't do 90 degrees because there's a right triangle. You can't have another right angle in a right triangle, so it goes to 89 degrees and it lists the values there. You're never going to have to use one of these things unless you're stuck on a desert island without a calculator or something like that, because we have calculators now that can look these things up for us. And there's two styles of calculators that I will find that students will be using. One is they'll be using their phone calculators. I have my iPhone here, and where is that thing? If I find the calculator here, oh, it's not on the home screen. Where is the calculator on my phone? I never use it, so I don't know where it is. But a lot of students use their calculator. There it is. Okay, I'm going to come back to this because I don't have it installed, but I will install it. And I will show you the other version, and hopefully it'll be installed here in a second. I forgot I removed it because I never use it. So, if you have a scientific calculator, a newer version of the scientific calculator, or if you have So if you have a scientific calculator, so here's a pretty typical scientific calculator, or if a graphing calculator, the way that you will enter look values up on your calculator is you'll see a sine, cosine, tangent button, and almost every one of them it's right there and you'll type it in just like we were writing it. So if I wanted to figure out sine 27, I would just type sine 27 and then hit enter, and it looks it up for me however it looks it up. So that's the value of sine 27. You notice this has a little DEG here on this calculator. That stands for degrees. There are two common ways of measuring angles that you'll encounter in high school. One is degrees, which is what we're going to be doing in this class. The other is radians. You're never going to work with radians in my geometry class. You'll encounter it in pre-calculus and calculus. So you want to make sure that your calculator is in degrees mode, not in radians mode. And in this one, there's a mode button that'll change it back and forth. A quick way to check that you are in degrees mode, if it doesn't show up here on the screen, is tangent 45 if you're in degrees is 1. So if you do tangent 45 and it doesn't come out 1, then you're going to have to figure out how to change your calculator's mode into degrees. So this is how you look them up in a graphing calculator and in modern scientific calculators. Here's the iPhone calculator, which a lot of students have. If you put it into landscape mode, it will have, it's a bad glare, there we go. Let me tip this a little bit, try to get rid of this glare. Let me just tip this like this. There we go. If you put it in landscape mode, you'll see it has sine, cosine, tangent. But here, you have to get the number in the display first, and then you press sine. Now, you have to be aware because this might be in radians or degrees, so you can check tangent 45. Okay, tangent 45 is 1. Here's how you change it between radians and degrees. If I tap this, it'll go to radians. Now that says rad. We don't want this in my geometry class, so if you go back and tap degrees again, like that. So how you look it up on these style calculators, you get the number of the display and then you press sine and it tells you the value like that. So I will be using this calculator for my work, a graphing or a scientific calculator, so I'll be entering things like this. So how do we use it to solve some simple problems? There's two basic varieties of problems. The first variety of problem is where you're going to want to determine an unknown side. So a problem like this. So let's get our mnemonic down here. So katoa. So we can keep track of the definition of the various trigonometric ratios. My first step is always going to be label this triangle for trigonometry. It's always the first step. Remember, we do hypotenuse, then the adjacent to the adjacent leg, and then the opposite leg. So hypotenuse is across in the right angle. That's the hypotenuse. Here's the angle that we're going to be focusing on. So this is the adjacent leg right here next to it, not the hypotenuse, but this one. And then this is opposite. So I look at now the side that I know and the side that I want to know. I know 5.8, which is the hypotenuse. I want to know this side here, x, which is the opposite. And then I look at my trigonometric ratios and figure out which one connects these two. So I have opposite and hypotenuse here. If I look at that, I see opposite and hypotenuse, that's going to be sine. So I'm going to be using the sine ratio. So what I write is I write sine. And remember, I always write the focus angle, 67 degrees. Sine 67 degrees equals, and then it's opposite over hypotenuse. So x over 5.8. So then I'm going to look up sine 67 degrees on my calculator. 0.9205. I always write down 4 digits so I don't get a lot of intermediate rounding inaccuracies. Then I just have to solve this for x. Here I have x divided by 5.8, so I multiply both sides by 5.8. And that tells me what x is. So I multiply this by 5.8, and I have 5.33, 5.34. What are the units on these inches? Let's do another example. So first step, label this triangle for trigonometry. There's the right angle. Hypotenuse is over here. Hypotenuse is always first. Then here's my focus angle. It touches hypotenuse and adjacent. That's the adjacent leg. Then across from it over here is the opposite. So now I ask the question again. Which trigonometric ratio involves opposite and adjacent? If I look at my mnemonic, opposite adjacent is going to be tangent. So I write down the tangent ratio. Tangent, always write the angle, equals opposite, 61, over adjacent, my unknown x. Bring my calculator out. Tangent 18 is 0.3249. So now I have to be careful in solving it. X now is in the denominator. So in order to get that out of the denominator, I have to multiply both sides by x. So those divide away. And then I get to divide by 0.3249. So I get 61 divided by that previous answer. So x is a big number. It's 187 with my units here. Millimeters? Millimeters. And if this is drawn anything like to scale, it should make sense. Okay, this is 61, and this is a small angle, and so this is a lot longer, and it ends up being, this is over tripled this length. What if the unknown is an angle rather than a side? So here's a question where the unknown is the angle. The beginning is the same. We set it up the same way. We say, all right, get this cord out of the way, there we go. I want to set this triangle up for trigonometry. There's the right angle, so this is hypotenuse. Here is my angle, so this is the adjacent leg, and over here is the opposite leg. And then I look and I say, okay, what are the two sides that I know? Like before, what are the two sides that are involved in the problem? Opposite and hypotenuse. If I remember my mnemonic, so katoa, opposite and hypotenuse is sine again. So I write down my trigonometric ratio, sine. Now I write the angle, but I don't know the angle. I just called it A. So, okay, so sine A is opposite 9.5 over hypotenuse 14.8. And I can use my calculator to get that. That's straightforward. 9.5 divided by 14.8. 64 rounds is 0.6419. But now this is something new. It's a new problem that I have before, that I saw earlier, where I've got sine A equals this, but I don't know what A is. I don't know what the angle is. Before, the problems before, we knew the angle. And so I just said, okay, sine 67 degrees, and I asked the calculator, and it told me what that was. But now my unknown is the angle. So I could look at a table of values and say, okay, sine A equals this. What's the closest angle? But again, we're not going to be doing that. We can use our calculators. In a sense, if you were thinking about it incorrectly but temptingly, what you want to do is you want to divide away this sin. You want this to go away. You want it to, so I just have A. Like if I had, 4A equals some number, then I would divide by 4, and I would get A all by itself. But this doesn't really mean sine times A. However, what we do is going to look a lot like division. This is actually function notation. If you remember any rules, language about how functions work, this is sine of A. What we're going to do is we're going to, in essence, divide away this sign. We're not really doing it. We want to do what's called the inverse sign. We're going to move this over here, divide it off. We're going to get this strange sign with the -1 as an exponent. It looks a lot like we've divided the sign away. This odd-looking thing here is read inverse sign. That's how you say that. And this, in essence, divides the sign away so that we have just the angle by itself over here. And we can access in the calculators by, here you can see on this calculator, you're going to press second, and then you'll have inverse sign. And it's the same on most calculators. There's going to be a second button that will switch this to inverse sign. So I have inverse sign. There's a glare. There we go. And then I type in my value. and I get the angle is around 39.9 degrees. So this is how you solve for an unknown angle. You set it up like we did the previous problems, but then you're going to do this inverse sine thing to move the sine away from the A so that you have just the angle all by itself. Let's look at one last example. So here we have an unknown angle question. We will start, as always, labeling this for trigonometry. Here's the right angle. So across from the right angle, we find the hypotenuse. There's the angle, so it connects the hypotenuse and the adjacent. And then across from the angle, we find the opposite. So now, I have to ask what trig ratio connects these two, adjacent and hypotenuse. If I look at my SOHCAHTOA mnemonic, adjacent hypotenuse is cosine. So I write cosine, angle, here the angle is my unknown A, equals adjacent, 8.0, divided by hypotenuse, 11.2. Dividing that, gives me 7143 if I round properly. So cosine A is 0.7143. And then I'm going to use inverse cosine to move the cosine away from A so that I have just A by itself. So inverse cosine of that answer is 44.4 degrees. And that is all.